In this section, you will learn how to use perpendicular bisectors. First of all, what is a segment bisector? Just to remind you, a line goes on for infinity, a ray goes on for infinity, so therefore they cannot be bisected. Only a segment can be bisected. So over on the right here, you see that segment XY is being bisected by line AB. It is creating two congruent segments, and the segments are XB and BY. A segment can be bisected, for example, by this segment here. It is also going through B, the midpoint. However, this segment, let's call it LM, is not a perpendicular bisector, whereas segment AB or line AB is a perpendicular bisector. A point is equidistant from two figures if the point is the same distance from each figure, or in this case, let's talk specifically about points. Points on the perpendicular bisector of a segment. So let's say this is the perpendicular bisector AB. So any point on line AB is going to be equidistant from XY. So the first thing is B is equidistant from X and Y. A is also equidistant from X and Y. A. So these two are also so this is congruent. If I were to put another point over here, let's say, and draw some more segments, these would also be congruent. Let me try and draw a segment here. Okay, not perfect, but it'll have to do. So let's see if I can fix that. Take the crooked one out. Okay, and so let's call this point T. So that is also equidistant from X and Y. Okay, perpendicular bisector theorem. It says in a plane, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. This is exactly what we saw earlier. So if segment AB here, if that's the bisector of segment XY, so XY is being bisected, then we are saying that XA is equal to YA, or that means that these will also be congruent. So any point on the perpendicular bisector is equidistant from the endpoints. Endpoints here are X and Y. The converse of the perpendicular bisector theorem says, hey, if I have a point, let's say point D, and if I measure the distance from D to Y and D to X, and the point D is equidistant from X and Y, then it follows that it will also lie on the perpendicular bisector. So that perpendicular bisector will actually go through D. And the given here is that dx equals dy. What follows is that it lies on line AB, which is the perpendicular bisector of xy. So focus on what's the given. Concurrency. So if you have 2 or 3 rays or lines that intersect, so here we go. Here we have a segment and a line, and they of course intersect in a point. Two segments, rays, or lines will also always intersect in one point, provided they're not skew, of course. But if I have a third line, then if that third line goes through the same point of intersection right there, then we say that point P is a point of concurrency. So let's say P here. There is something very special about the perpendicular bisectors of a triangle. If you look at this diagram, P segments that originate from P, we could say ray PD, ray PE, and ray PF are the perpendicular bisectors, and they intersect, they're concurrent at point P, or they intersect at point P. This point P is very special because it is going to be the same distance from the 3 vertices of this triangle. So C, A, and B, which has sort of moved over here, but let me just rewrite that. So this is B. So we're saying PA, PB, and PC, these highlighted ones will all be equal in length. They will be congruent, they will be equal in length. And then this leads to something very interesting. Because that point P is equidistant from the vertices, we can use that point P as the center of a circle, and the radius of the circle would be the distance between P and a vertex. And when the triangle that you draw is acute, then the center of that circle is inside the triangle. And you will see this when you do your construction project. In a right triangle, the center of the circle is on the hypotenuse. In fact, it's on the midpoint. The radius will be these dashed lines, dashed segments starting at P. In an obtuse triangle, the circumcenter, the point P, which is the point of intersection of the perpendicular bisectors, will lie outside the triangle. So the actual radius will be, and I'm going to use the color red here, will be So this is going from that point to the three dashed red segments are the radius of this circle. The point P is outside the triangle. I just want to go back to the acute triangle, and here what I'd like to do is once again, let's see what the well, I didn't do that too well, did I? Let's try that again. Okay, so that and that. So those green segments, those are the radii, and if you can't see them, I'll highlight them